Having two eyes rather than one.
Yes, it's a good news, bad news day.
Oh, thank you, Mr. President. Oh.
Okay, so that's what we're going to go through here is that there's two types of lenses, and for what we're going to deal with, which is going to be concave or convex. And then there's two types of mirrors, concave and convex.
Even though concave and convex mirrors are just this, never mind, just keep going. I should stop talking for a while.
Okay. So, what I've given you is a concave mirror or a convex mirror, depending upon your perspective. Okay?
No pun intended.
So, here's the easiest way to remember something is concave. It's like if you're a cave, you can walk into it. Okay? So the concave side of the mirror is going to be this side, and the convex side is going to be that curved side on the back. So if you have, and the same thing is true of a lens. If you have a concave lens, it's going to be shaped like this, and it's like the entrance into a cave. If you have a convex lens, then it's going to be shaped like this. Okay? So, concave, convex. Now, the other terminology that you will use is converging and diverging, okay? In terms of what happens with the rays. So, to show that, grab the camera. Let's go to the back of the room for just a second. We kind of got to transition.
Bring the mirrors.
No, leave the mirror. Don't take the mirrors for now. We'll deal with the mirrors in just a second. Okay.
Whoa.
Oh, come on.
Dark nights are upon us.
So it's not
I am a boomer.
Boomer
eyes.
I'm going to turn the light on for just a second so I can see plug this thing in.
You preemptively turned off. I did.
Never mind, I got it.
We're the perfect combo.
I am a genetic.
I got it.
Falls.
Ooh. Okay. So, all this is just a light source, and it's sending out some like parallel rays. So what I'm going to do is I'm going to show you the four like generic types of lenses and mirrors. So let's start with this, which is, you look at this, right? So this is a concave lens. So what happens is that with that concave lens, if you notice, what it's doing with these rays is that it's making these rays diverge. Okay, so they're kind of parallel, right? You put those in, and those lines come out. So what's happening is that these rays are coming in, it's going through these lenses, and it's going to get spread out. So one of the things that we'll talk about is something that's known as a real or a virtual image. So if that light is being spread out, okay, and not brought together to a point, that means you can't project it onto a screen. Now, I could look over here, like I could put my eyeball here, and here's what's going to be important. When you're actually looking, if my eyeball was over here, you're going to see those lights together coming from a point, but they're going to be diverging out on this side of the lens. Now, in contrast to that, if I put a convex lens in here, then these rays are coming in, they're going through here, and now they're being brought together to a point. So a convex lens will bring these together.
Isn't that how your eyeball works?
Yes, exactly. A concave lens will spread these out. Okay? So concave lens spreads them out, convex lens brings them together. Now, in contrast to that, you can have mirrors. So here I've got a convex mirror because it's curved out like this. So that's going to be, I'm going to turn this a little bit so that's easier to see. So what's happening here is that when those rays are hitting the surface, they're bouncing off in all directions. So if I'm over here looking at this, what I will see is that the object is going to look bigger than what it actually is because of the fact that I'm here like this, and when I'm looking at it, it's going to look like these rays are coming together from a point. So and this gets weird when you talk about what these rays are doing versus what you are actually seeing. So if, on this one, when I've got this mirror like this, okay, is that it's taking those and it's pushing those rays apart. So this is diverging. Now, if you have a concave mirror, then that brings those rays together to a point. So here's the difference. If I've got a concave mirror, it brings the rays together. If I've got a concave lens, it pushes the rays apart. But if I've got a convex lens, it brings them together. But if I've got a convex mirror, it spreads them apart. Okay, so they're going to operate, and they're kind of like opposites of each other. So what you need, and you can figure this out just based upon logic. So if you can figure out what happens with one of them, you can kind of apply that to a bigger idea, going, oh, hey, here's what's happening. So if I look at this and go, okay, hey, I got a mirror, it's going to spread that apart. Okay, that's diverging. Now, what you can do is kind of combine them. So if I do this, so let's say so here I've got this concave mirror, and I really want to bring that together to a point. So would I grab a convex lens or a concave lens? Convex. So if I do this, okay, and then I take that convex mirror, okay, so that light's gone through.
Is that how your death ray worked? The convex one?
No, because that was just one big lens.
Oh.
But what's happening here is that these rays are coming in, then they're hitting the convex lens, and it's starting to bring them together a little bit. Then this mirror then is sending them back through, and then I'm really focusing those rays down to an exact point. So, but I couldn't do that, okay? So if I've got this mirror, because this mirror is spreading it out, then if I put that convex lens on the other side, then it's just making it even more spread out, because this concave lens is making them spread out. It's hitting this, which is making them spread out. Then when they come through again, then they're even getting them more spread out. So you can put them in combination with each other. So here's what you need to begin to do. You need to begin to sort through, like, okay, I'm going to figure out one of these. Because if you can figure out one or two of them, then you can figure out what's going to happen with the rest of them. So any mirror or lens is either going to do one of two things. It's either going to be convergent or it's going to be divergent. So that's why I don't necessarily like concave and convex. I prefer that you say, hey, here's the divergent lens, here's the convergent lens. So one of the things that, well, this will play out mathematically later on, is that whether it's a lens or a mirror, if it's being brought together, if that light is being brought together, it's going to have a positive focal length. This will make sense in just a little bit. So you can think of this in terms of people. If someone's has a converging personality, okay, and they bring people together, they tend to be pretty positive people, like, hey, I want to be around them. Let's all work together. If someone's divergent, then people tend to view them as being kind of negative. It's like, oh, right, yeah, Skippy's a jerk, right? Yeah, he's pretty negative. He walks into the room, he's like social napalm, and everybody just kind of scatters. Nobody wants to be around him. Okay? Got that idea. Okay, so back we go.
So we're not talking about the Divergent book series?
No.
Unfortunate.
These are old honors physics tests. No, these are old honors physics tests.
Uh-oh.
I thought it was something I thought it was my test. From class.
Whoosh.
Okay, now with that said, so what you have is a mirror that's got a concave side and a convex side. So what I want you to do is, because I'm not going to talk for a while, okay? So what I want you to do is I want you to hold it up and start with it close, with like maybe the concave side first. I don't care which side you start with. So I want you to hold it up close, look at it, and then move it further and further and further and further away, and then see what happens. Then I want you to flip it over, and then I want you to do the same thing. I want you to start with it really, really close, and then move it further and further and further and further away, and see what happens on both sides. Okay? So take about 5 minutes, pass that around so that everybody has that chance. Hold it up close, see what happens, move it away, see what happens. Hold it up close, flip it over, hold it up close, move it away. So, all right, man, stop though.